Okay, we got an initial value problem, and the information that we start with is that the third derivative is equal to 6. And we also have this information over here, which the first one says if we plug in 0 into the original function, we would get 5. If we plug in 0 into the derivative, we get 0. If we plug in 0 into the second derivative, we get -8. This is going to help us work backwards to figure out what the original function was. Okay, so we start with the third derivative. We start working backwards. If we anti-differentiate from the third derivative, we would get the second derivative. And we have to think about this backwards. What would have given us 6 if we took its derivative? Well, 6x. If we take the derivative of 6x, it would have given us 6. So if we work backwards, then we get a 6x. We also have to put a c here because we don't know if there was some constant here, like 1, 2, 10, 1/2, negative, whatever, that disappeared when we took its derivative. Okay, that's what we're going to use this information over here to figure out what that c is. Okay, so this is second derivative information, y double prime, or in this form here. Okay, so we can use y double prime of 0 is equal to -8. We plug in the 0 for x, 6 times 0 plus c, and we set this 6x plus c equal to -8. Since that goes away, c is equal to -8. Thus we get that the second derivative is equal to 6x minus 8. Okay, now we're going to repeat the process. We now work backwards again. So if we take the antiderivative of the second derivative, we would get the first derivative, dy dx. Okay, so undoing this, we would say, okay, well, we would have to add 1 to the exponent. The 1 would turn into a 2, and instead of dividing or multiplying by 2, we're going to divide by 2. Okay, to undo this, which will turn into a 3x squared in our next step. The -8 would be basically just tack on an x, because the derivative of -8x is -8. Okay, plus c1. The reason I put c1 there is because this constant probably is not the same as this constant, so we have to give it a different title. Okay, if I clean that up a little, we get this, and you can always test by taking the derivative of this and see if it would have given us this. The derivative of 3x squared, to bring the 2 down, turns into a 6x. There it is. Derivative of -8 is, or -8x is -8, and the derivative of a constant would go away. So we need to now figure out what this constant is. Okay, so we use this information. Y prime of 0 is equal to 0. Plug in a 0, set it equal to 0. 3 times 0 squared minus 8 times 0 plus c1 equals 0. We plugged in 0, we set the equation equal to 0. These two go away, c1 is equal to 0. Thus, the first derivative function is equal to 3x squared minus 8x. We don't need the c1 because it's a 0. Now we've got to do this one last time and then we're done. So we undo this derivative. We'll bring us back all the way to the original function. Okay. Again, we add 1 to the exponent. We divide by that same number. Do the same thing to the -8x. We add 1 to the exponent. We divide by that same number. And then we put c2. Again, not the same constant as the first two constants. So we put a c2. Okay, so clean this up. Y is equal to x cubed minus 4x squared plus c2. We're going to use that last bit of information that if we plug in a y, it's equal to 5. So that means I'm going to plug in 0 cubed minus 4 times 0 squared plus c2 is equal to 5. Cancel those two out, and I get c2 is equal to 5. And my final answer is y equals x cubed minus 4x squared plus 5. That is the starting function. If you take this derivative 3 times, you'll get 6.